Hi, this is Jason Molesky. In this example, we'll construct a confidence interval for the difference of two population proportions. As a part of the Pew Internet and American Life project, researchers conducted two surveys in 2012. The first survey asked a random sample of 799 U.S. teens about their use of social media and the internet. A second survey posed a similar question to a random sample of 2,253 U.S. adults. In these two studies, 80% of teens and 69% of online adults use social networking sites. For this problem, we'll calculate the standard error of the sampling distribution of the difference in sample proportions. Then we want to know what information that value provides. Next, let's construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. Well, first let's calculate the standard error of the sampling distribution of that difference in sample proportions. The sample proportions of teens and adults who use social networking sites are p hat 1 equals 0.80 and p hat 2 equals 0.69 respectively. The standard error of the sampling distribution can be found using the formula square root p hat times 1 minus p hat 1 over n1 plus p hat 2 times 1 minus p2 divided by n2. Inserting the values we were given in the appropriate places, we see that the standard error of the sampling distribution p hat 1 minus p hat 2 is 0.0172. What that means is if researchers repeated the random sampling process many times, the difference in sample proportions will typically be about 0.0172 from the actual difference in the population proportions. Next, let's construct and interpret a 95% confidence interval for the difference between the proportion of all U.S. teens and adults who use social networking sites. Well, we know that N1, the sample size, is 799, while p hat 1 is 0.80. Our second sample size was 2,253 for the adults, and the sampling proportion p hat 2 was 0.69. For a 95% confidence level, the critical value is z star equals 1.96. So our 95% confidence interval for P1 minus P2 is given by our confidence interval formula, where we have our estimate, the difference in our sample proportions, plus and minus a critical value times the standard error of the sampling distribution. So in this case, inserting the information we were given, our estimate will be 0.80 minus 0.69, plus and minus a critical value of 1.96, times our formula for the standard error. 0.11 is our observed difference, plus and minus 1.96 times that standard error that we calculated, and we receive a lower bound of 0.076 and an upper bound of 0.144 when we do the calculations. So to interpret that, we can say we are 95% confident that the interval from 0.076 to 0.144 captures the true difference in the proportion of all U.S. teens and adults who use social networking sites. For some additional practice in calculating a confidence interval for P1 minus P2, try exercise 9.